Hello and welcome to yet another tutorial video. This particular one, as you saw from the title, is optimization techniques for VRChat. First off, let's talk about what is optimization. Optimization is when you take a model and you do various things to it and you optimize the time spent that your computer or the time that your computer spends drawing it onto your view. Now, because we're using VR and VRChat most of the time, this is of course the same for desktop users, performance is pretty important because we're drawing these frames 90 times per second. We are drawing them on two eyes at very high resolutions, and the headset is not very tolerant of FPS drops. So what we want to do is we want to try and reduce any kind of things that may cause our performance or others' performance to drop. It's important. Optimization is important because if we don't do this, then pretty soon we'll have lots and lots of models that are very badly optimized. Once you get At this point, if you get around 50 people in a room, then no matter what CPU or GPU you have, you are going to be sitting at 30 FPS. To point out something that also I should make clear here, there is a little bit of a misunderstanding for what drives performance and performance loss in VRChat. As far as the community understands it right now, CPU is actually what the bottleneck is in VRChat. If you have 0 people in a room and you're just looking at a scene, and then you add 50 people to the room, and then you look at the performance of your CPU and your GPU, you're actually going to see your CPU capped out at 100% all the way, and your GPU is going to be sitting at like 20 or 30%. Even with a not completely up-to-date GPU, I've got a 1080 and it usually idles around 30% utilization when I'm in VRChat. The highest I've ever seen it go is 50%, because beyond that, the CPU doesn't have the time to be able to pass draw calls and other things to it faster than that. In other words, we are bottlenecked at the CPU level. So I mentioned draw calls there. What are draw calls? Basically, a draw call is the CPU instructing the GPU, and let me define these really quickly. Your CPU is your processor, so it's like your i7 or your i5 or your Ryzen processor. And your GPU is your graphics card, which is like your NVIDIA 1080 or your Radeon R9 290X or whatever. The minimum requirements for VRChat are an i5 4000 series, I believe, and a NVIDIA 970. Now, lots of people run with specs lower than that, but performance can't really be guaranteed, especially in virtual reality when you are below those specs. So draw calls in this respect basically are when the CPU, your processor, talks to your GPU, passes it information saying, here's a mesh, as in the vertices that are in your model, here's a texture, and here's some shader code. Run the shader code using these resources and give me the output from it. Your GPU is really good at these draw calls. Like, it can process them very, very quickly, and it passes it back to the CPU. The problem isn't in waiting for the GPU to finish a single draw call. The problem is when the CPU has to pass hundreds of draw calls. So I've got a scene set up with an unoptimized model. So I've got Cerno here, and I'm going to show this cool thing called a frame debugger. If you want to pull this up, I have it in a tab form down here. In Unity, you can just go to, I believe where's Profiler here? Right there. You just click that and it'll bring it up in a separate window, but I have it in a tab down here. Hit Frame Debugger and you go automatically into game mode in the background here, and you see this new window come up called Frame Debug. And you'll see that there's quite a bit of things here. What you're looking at is the draw mesh calls, which are effectively a draw call in this context. You can see that there's a lot of them. What we're actually going to do is I'm going to draw it back into scene mode, look at my directional light, and I'm going to turn shadows to no shadows. So shadows cause another draw call, and if we want to standardize basically where our draw call counts come from, then we want to turn that to no shadows so that it doesn't actually draw the shadows. So now we can see that there are quite a few draw calls here. It looks like there should be 53. I think that's what that number means there. Yeah. That's probably correct. So this step down here is step 54. This step up here is 2. So we actually have 52 draw calls for the model itself. You will always have a draw call in Unity for the skybox in the background here. You can disable that in the camera. And there's also an extra draw call somewhere else, I believe. But basically, there's a lot of draw calls here. There's a huge amount. There's 52 of them, and that is a large amount. In older versions of cube shaders, and I'm using cube shader for this model here. In older versions of cube shaders, it would actually have a multiplier of 3. So every single mesh that would be every single material that would be drawn with cube shaders would actually have a multiplier of 3 on the draw calls. Thankfully, that has since been fixed. So that covers what a draw call is and why it's bad. Actually, I didn't really cover why it's bad so well. Basically, all those draw calls, each one is the CPU sitting and waiting for the GPU to finish its job. When it's 1 or 2, no big deal. It gets done pretty quickly and the CPU can move on to other jobs, such as rendering other people's avatars. But when you've got like 10 people in a room, with each having like 50 or 75 or even having 100 draw calls, that adds up very quickly and your CPU ends up sitting and waiting and delaying the frame for waiting for the GPU to finish this giant amount of draw calls. And it has to do them in serial. It has to do them one by one by one. It can't do them in parallel. But you can help the GPU by reducing the amount of draw calls that you actually make to your GPU. So I touched on what causes draw calls very quickly, but I'll go into a little bit more detail here. Each separate material that is on your model, so this is a very badly optimized one, each separate material causes a draw call. So each one of these that is applied to the model that is passed to the graphics card is basically a texture and a shader and the shader settings, and it is passed to the graphics card. The graphics card processes that material on that particular bit of mesh that it's applied to, and then pushes it back out to the CPU. So this happens over and over and over and over until you get through all of them. Obviously, if we've got, how many materials do we have here? Well, like, how do I even, 51. So actually you can see that that is kind of close to the number of draw calls we had. And the reason why we have one more than that is because of this. I have one skinned mesh renderer on this model. Skinned mesh renderers are basically it is a component in Unity that go typically on characters that have an armature. The fact that it is a skinned mesh render instead of a static mesh render means that it can be morphed, as in if you move a bone, it will morph the mesh. So each one of these mesh renders has a draw call. Each one of these materials has a draw call. But now what's even worse is if you have tons of meshes, say you have 5, and you use all of your materials on all 5 of those, now instead of having 50 draw calls like I have roughly here, I would have 50 times the number of skin mesh renders I have. So that would blow it up immensely. So instead of 50, I would have 250, which is obscene. Do not have 250 draw calls. That's bad. So, additionally, and this is something you can't really do too much about, but you can if you're building worlds, doing real-time lighting with lights and shadows will incur a lot of extra draw calls, as you saw. When I had real-time lighting on, it actually multiplied the number of draw calls, I believe, by 3. So we can check that out again. So we're going to set it real-time, we'll set it to soft, and then let's go to the frame profiler again. And you can see that there's a ton there, there's a ton there, there's a huge amount. Yeah, it's multiplied by looks like roughly 3. More than that, actually. It's at 221 now. Can I turn this off live? Yeah, 258 versus 221. So if you have a lot of real-time lights, and that's just from one dynamic light or one directional light with shadows on soft with real-time. So you can see that that causes quite a few issues, or it could kind of propagate issues with bad models. So I've given you basically what draw calls are, what causes them, why they're bad, and why it's important to reduce them. So how do you do this? Pretty simple, actually. We have 2 methods by which we can reduce draw calls, and I'm just going to import some MMD here. I'll probably just bring in Cerno. Let's bring in an owl. Here's a cute owl. So we have this cute owl. She's kind of big because I didn't adjust the scale. She's also pink. By the way, thanks to the people who told me you just unclick toon texture and that makes them not pink. So anyways, this model currently, the let's do some of the basic cleaning here. Just delete joints, delete rigid bodies, and delete the parent item here. So now we can see that it is already one mesh. But the reason why a lot of people may have their MMDs split out into a lot of meshes is because they do this. They do the separate by materials trick to help with decimation, which is what I would have to do in this particular case. But then they don't remerge them after they're done. And look how many different materials this particular one has. It's a huge amount. Like it's absolutely massive. So if each one of these was put in, thankfully each one of them only has one material, so it would only be this number of jar calls, but you still want to join them together. And the cool thing is it's very easy to join together separate meshes. Let me turn on my on-screen display real quick. Let's see here. OSD, no. Display tools, no. Key, screencast keys, that's what it's called. Let's turn that on. So you'll have down here a display of what I'm pushing and exactly. So you can see I can push A and push A and Z and then Z. There you go. See? So anyways, let's split it again by materials. So now we have all of these meshes. How do I join them? It's super easy. You just shift click on each one, which can be a little bit tedious, but I haven't found a better way to do it. Go out into the 3D view, hit Control and J. There you go. You now have one mesh. That's it. That's all you have to do. It's dead easy. I covered this in previous videos, but people still seem to be forgetting it. Or maybe they just, skipped over that part of the video, whatever. But it is extremely easy. So that's how you join meshes. And again, it is very easy compared to what I'm about to show you. What I'm about to show you is a rudimentary explanation of something called texture atlasing. So if we look at the materials that we have on this model, there's a lot. There's a large number of materials. Actually, I'm going to show you something else first. You can see, however, that a lot of them are duplicates. Like all of them use this same texture. They all look exactly the same down here. See, these are different, but these are the same. There's an easy way to fix this, though. So we can reduce this model, I believe, if I'm recalling it correctly, I can reduce this model from all of these materials down to 4. So here's how we do it. First, we go into Edit View here by pressing Tab in the 3D view. Select the first material and hit Select. And then click the next one that looks like it has the same one, and then hit Select. And do this, and I'm using arrow keys. Remember, you're in Blender where your cursor is matters. So I'm using my arrow keys to quickly go down through this list and select everything that looks like it has the same texture. And I can verify this by looking down here in the preview. You can also set this to flat here so you can make sure for reals. And then there, and then there, and then there. Cool, great. So now I've got all of the different materials selected that use the same texture. I select one of them, doesn't really matter. I hit Assign, and then I come back out of Edit View. I will call this one, I don't know, this looks like eyes, so we'll call this eyes. Also, you will need to enable, what is this plugin called? It comes with Blender. Material Utils Specials. So find this and check it and enable it, and then hit Save User Settings so that you actually save it. So once you have that plugin enabled, you can now click on this little down arrow, go to Clean Slots, Clean Material Slots, and any materials that are unused anywhere on the mesh are removed. So let's do the same thing for the hair, which is very easy on this one. We're going to open up Tab, hit A to unselect everything, select bangs, select wing, select hair. And those are the 3 that have, yeah, that's what it looks like. Those are the 3 that have the same texture. They all use this texture here. I'm going to choose hair as the one I want to have it as, just because. Hit Assign, come out of edit mode, name this hair, click here, clean slots, clean material slots. So again, we have gone down from like the list being all the way down here to being only this far, and we've only done 2 out of 4. So let's do the same thing here. Unselect everything, select, 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 select. This looks like skin and face, so we'll just call it skin. And we'll hit Assign, come out here. Oops, wrong one. We'll call it face. We'll call it skin. I changed my mind twice. Hit that, hit clean slots, clean material slots, and there you go, they're all gone. Now, here's something that you will run into some issues with. Some of these materials are going to be blank because they don't use a texture. Actually, this one does use a texture. Interesting. So if something weird like this pops up, what you can do is go into edit mode. If you hit select, it will select what part of the mesh is using that material. In this particular case, this is a kind of face gradient. I usually actually delete these because they don't look too great once you import it and use MMD, or not MMD, but when you use cube shaders. So I'm going to just hit delete verts. So that's now gone. I'm going to also do the same thing for flush. Yes. So I'm going to select flush. Again, how I do that, once again, hit the material you want to select, hit select. It selects the verts that it is applied to, hit delete, hit verts, it's gone. Now, because those materials are no longer assigned to any verts on the model, if I hit clean slots, those two will disappear. And then finally, we have 4 more materials to merge. 2, 3, 4. This looks like clothes, so we'll call that clothes. We'll assign that here, come out, hit clothes, and then hit clean slots. So now we have taken, all those materials. What was that like? I'm just gonna guess that was like 20, and we've dropped it down to 4. That's already a pretty dang good job. Like that's already quite a bit of work done. This particular model has some interesting, oh, okay, that'll be fixed once we apply cube shaders. That shadow is kind of wigging me out a little bit. I think we can actually delete this. What happens if I do this? Oh, there you go. You get eyebrows back. Okay, well I guess that was just a quirk of this model. So anyways, what we can now do is something called texture atlasing, which is what I called it way back when I started doing this process, but then forgot we needed to merge materials in the first place. So texture atlasing is the act of merging all of the textures into one giant atlas or image. And instead of us having 4 different textures like we do here, we will have one texture, which means we can have one material, which means that if we have one mesh and we have one material, we now have one draw call, which is as optimized as you can possibly get. So that's relatively easy to do on this particular model. So what you'll need to do first is, again, open up the user preferences. I use Control-Alt-U, as you saw down there. You can also go to File, User Preferences, either way. Search for, in the Add-ons tab, Atlas, and you'll find a script called Texture Atlas. It'll probably be disabled. Just hit the checkbox, hit Save User Settings, and close it. What we'll then do is we will go to the Render tab here, and at the very bottom you'll see this thing called Texture Atlas. Hit plus. I'm just going to go with the default name of Texture Atlas, and hit OK. You'll want to choose a sufficiently large resolution. Basically what you're doing here is you're specifying the resolution of the output texture. I've done this model before and a 4K texture was more than enough. So we're going to hit that, make sure that I have the mesh selected, which I do, and I'm going to hit Start Manual Unwrap. So now what it has actually done is it created a second object to do what's called a UV unwrap on. I'm going to, and let me actually point out what I actually did here so it's not just, what I did is I grabbed this little handle in the top right of the toolbar and I drag it over, and that basically splits my view here. I'm going to switch this over to UV Image Editor. I'm going to go down here to Browse Image to be linked, and I'm going to find Texture Atlas and then click on that. And now I have the Texture Atlas here. This is kind of like the background default demo image. Now, what I'll do is I'll hit Tab in the 3D view and make sure you have everything selected, and you'll see this pop up. And this is a UV map. This is a very bad UV map right now, so what I'm going to do is I'm going to move my cursor into the UV mapping area, hit A to select everything. I'm going to hit Pack Islands. And what this will do is it will kind of organize your entire mesh onto this map here so that it knows where to look for the texture. So UV mapping is basically telling a mesh, or rather, to be more specific, it is telling a shader that has passed a mesh and a texture where it should look on the texture for that particular color to be displayed. I'm not going to go too far into it here, but basically this is how you put how you would tell what part of the texture should appear on the model at any given point on the model. What I'm also going to do in this particular case is I'm going to increase the margin a little bit. Let's bring that up to like maybe 0.3. Try that. That didn't do anything. Let's do like that. There we go. So the margin basically determines, well, like in a Word document, the margin around each one of these UV maps. So now I've pretty much finished the manual unwrap. This can be a difficult process if your model is kind of weird. Especially if you've already done decimation and you've got a lot of loose parts, you may get a lot of weirdness here. This model I haven't decimated yet. I haven't really been able to determine if it's best to decimate first or if it's best to do texture atlasing first. You kind of have mixed results either way. Another thing that may help, and I've mentioned this in another video, but I'll mention it again here. If you go into the 3D view with all of your verts selected, hit W, and then hit remove doubles. That will remove a bunch of verts that may make it a little bit easier for you to pack islands here. So it may be a little bit more efficient. In this particular case, I can't really tell a difference. So anyways, we're done with the manual unwrap. So let's hit finish manual unwrap. And there you go. So now what we need to do is we need to select our model, and we need to go over to each one of these materials. It looks like it's actually fine. Yeah, it's actually fine. I don't have to do anything. So let me tell you what I sometimes have to do just so you don't get confused if it happens to you. If you've got your model looking crazy, like if it looks completely wrong when you switch after you do the texture atlasing, like it's just a mishmash, then what you may have to do is you may have to go to each material, go to the texture, and then go down to this map down here and choose UV map. UV map is the original mapping that we imported the model with. Texture atlas is the one we just created. But for the moment, we want to leave it as UV map. So I'm not going to touch this. So after you've done that, if you have to, and when you swap it over, head back over to the render tab. We want to open up the bake section. So what we're about to do is something called baking textures, which is essentially the Blender is going to sample the textures for the model where they're assigned, and it is going to write a new texture for us, the atlas itself. So what we're going to do is we're going to change this over to textures. We're going to probably leave most of this as is. Let's change the margin to 32 from 16, so we'll double it. This is the same thing as the margin from before, but it'll just basically pad all of the pixels out to a certain area or a certain distance that you specify here. So now that we've chosen it and that we have texture atlas here, let's just go ahead and hit bake, and this should work. If your model is particularly large, or if the textures are particularly heavy, or large rather, I guess is the right word for it, then this process may be extremely, it may take a long time, a very long time, and it's going to hit your CPU pretty hard. This one is, oh wow, I'm getting a lot of problems here. What's happening? Interesting. Live TV. Oh, I froze up for a moment there. Let's go ahead and stop this because this isn't working right. So we've run into a problem. If you start to see textures drawn on top of each other, it means that your UV mapping isn't perfect. So let's open this up again and take a look at the UV map. Oh yeah, for some reason it didn't take my mapping. So let's hit Pack Islands again. Interesting. Let's go ahead and continue as if nothing was wrong. We'll hit Tab to come out of Edit View. There we go. Now she looks all messed up. So now what we have to do is I'm going to have to do that little swap over thing. So let's go to each separate material. Thankfully, I only have 4. I think my Cerno actually, before I do this, has around 12, so this is rather tedious. Go to each one and change it over to UV map. So now what we're going to do is let's do bake again. Let's hit bake. There we go. That's what I want to see. Well, the advantage of doing this live is that you guys can see common mistakes and hopefully avoid them. So you can see that it's basically drawing all the different textures for this model onto here. You can see that there are the hands there, there's the eyes, there's a bunch of shapes that are inside of the head, there's the hair and the body and all that kind of stuff. And then you can see it pads it out and adds some transparency where it's needed. So yeah, now we have a UV map and we have a texture. So what we're going to do is we're going to save this image. So let me go back. You go to Image, Save as Image, And we're going to go to the owl, and we're going to call this Demo Texture Atlas because I've already done this a couple times. And there you go. So now we have the texture atlas, and we have the actually saved, and now we have the UV map done as well. So let's get rid of this panel, and I'm doing this just by dragging that handle over to the right. And now let's go over to our materials, and now for a kind of nerve-wracking part, we're going to delete every single one of them. And we're going to create a new one. Well, let's just call this Atlas. And then we're going to go to Texture. We're going to create a new one. And we're going to call it Atlas. And we're going to hit Open. We're going to find the one that we just built, which is Demo Texture Atlas. Hit Open Image. Make sure the mapping is set to Texture Atlas. And then finally, hit Shadeless. And there we go. We have it. So there are some problems you're probably picking out immediately. First off, the transparency isn't quite right here. Don't worry, as soon as you bring your model in into Unity with this, you will have transparency here. It just doesn't display properly in Blender Render for some reason. But don't worry, it's fine. On top of that, the colors may be slightly different. If the colors are slightly different, you can play around with shading here. I've had some success with turning off shadows and things like that during render. I've also had situations where it just wasn't playing nice, so I simply just edited the texture atlas and lightened it up in paint.net or something. So now what we can do is let's go ahead and delete the old UV map. So we have texture atlas here, we have UV map here. We're going to hit minus to delete that, and let's just rename this UV map. And then we'll have to go back and change this because it can't find that one anymore. So that's it. That's all you really have to do to texture atlas. I know it's pretty detailed. There are a lot of things that can kind of be unique per model. If you want to be able to apply a separate fancy shader to a different part of your model, then you're going to have to keep that as a separate material. But that gets a little bit more complex than I'm willing to go into here at the moment. But that's basically it for texture atlasing. So as a whole, that is how you optimize a specific model for draw calls. So let's go on to one more subject before I finish here, and that is dynamic bones. So you can see this model, I believe, has some dynamic bones on it. Oh no, this one has nothing. Let's find one with dynamic bones. What about 5.6 or no? Don't save. Ooh, you're purple. Why are you purple? Is the shader broken? Let's find Cerno baseline, I believe is what she's called. Either way, so Dynamic Bones is a script that you can purchase off the asset store, and it is $20, I believe, and it's really cool, and it lets you do a lot of cool stuff like having hair that moves around and stuff along those lines. You know, I'm just gonna do this with the purple thing because it works just fine. So you can see these little, it actually makes it easier to see. You see these white lines with the little circles? Those are all dynamic bones. And when I go into play mode here, despite the shaders all being broken, you can still kind of see the skirt move around and the hair move around and the bows move around. So this looks really nice, right? It's all calculated on the CPU. So this is not done via GPU processing or anything like that. All of this is calculated on your processor. If you have too many of them, for example, 76 as there are in this skirt, you will cause lag. You will cause lag if you use a huge amount of them. If you have them in a large chain like this. But it's basically a massive physics calculation that's done separately from the Unity physics calculation. So it's not too well optimized. So don't use too many. On top of that, VRChat restricts it. You can see here in the settings that you can have, oh wow, I had this set to 180. This must have been a real early version. So the limit that it'll force you to use is 60. 60 is the rate at which the updates will occur for the different bones. As in, if it's set to 60, it's done 60 times per second. If it's set to 180, like I stupidly had it set before, it'll do 180 times per second, and your CPU will cry and melt and crawl out of your case and probably try and choke you to death while you're sleeping. There is also animation culling in VRChat. The culling for animation occurs at around 20 meters, and what that means is that if you are more than 20 meters away from someone that is using dynamic bones, the script will stop running. So this helps quite a bit for crowded rooms. I would strongly suggest using fewer dynamic bones. Try not to use too many at all. Like I would say that you should set a personal limit of like 10, 20 maybe, and beyond that you should really be careful. There is the possibility of using character and hinge joints with rigid bodies. I have not really experimented much with them yet. No one has used them very well on MMDs just yet, but some people have used them on their own from scratch models to great effect. Clem's avatar in particular with his gem wings use, I believe, rigid bodies and hinge joints, or maybe character joints. I'm not really sure. But yeah, basically just experiment and try it out. I've been watching around tutorials for hinge joints and rigid bodies and stuff like that. I haven't gotten it really to work yet for character models, but who knows. But that is basically it. This was a video to cover optimization for VRChat with Unity techniques and Blender techniques. Again, this is a very quick overview video, despite it being 30 minutes and 32 seconds long at this point. But I hope this helped you out. Thank you.